Medical textiles have a need for repellency to body fluids such as blood, urine, or sweat that may contain infectious vectors that contaminate surfaces and spread to other individuals. Similarly, viral repellency has yet to be demonstrated, and long term mechanical durability is a major challenge. Masks, gowns, and other personal protective equipment (PPE) are essential for protecting healthcare workers. However, the textiles and materials used in such items can absorb and carry viruses and bacteria, inadvertently spreading the disease the wearer sought to contain. When the coronavirus spread amongst healthcare professionals and left PPE in short supply, finding a way to provide better protection while allowing for the safe reuse of these items became paramount. Research from the LAMP lab at the University of Pittsburgh Swanson School of Engineering may have a solution. The lab has created a textile coating that can not only repel liquids like blood and saliva but can also prevent viruses from adhering to the surface. The work was recently published in the journal ACS Applied Materials and Interfaces. Recently, there has been a focus on blood repellent surfaces, and the PIT researchers were interested in achieving this with mechanical durability. They want to push the boundary on what is possible with these types of surfaces, and especially given the current pandemic, they wanted to test against viruses. What makes the coating unique is its ability to withstand ultrasonic washing, scrubbing, and scraping. With other similar coatings currently in use, washing or rubbing the surface of the textile will reduce or eliminate its repellent abilities. The durability is very important because there are other surface treatments out there, but they are limited to disposable textiles. Given the PPE shortage, there is a need for coatings that can be applied to reusable medical textiles that can be properly washed and sanitized. The researchers put the new coating to the test, running it through tens of ultrasonic washes, applying thousands of rotations with a scrubbing pad, and even scraping it with a sharp razor blade. After each test, the coating remained just as effective. As this fabric was already shown to repel blood, protein, and bacteria, the logical next step was to determine whether it repels viruses. The researchers chose human adenovirus types 4 and 7 as these are causes of acute respiratory disease as well as conjunctivitis, that is pink eye. It was hoped that the fabric would repel these viruses similar to how it repels proteins, which these viruses essentially are, that is, proteins with nucleic acid inside. As it turned out, the adenoviruses were repelled in a similar way as proteins. The coating may have broad applications in healthcare. Everything from hospital gowns to waiting room chairs could benefit from the ability to repel viruses, particularly ones as easily spread as adenoviruses. Adenovirus can be inadvertently picked up in hospital waiting rooms and from contaminated surfaces in general. It is rapidly spread in schools and homes and has enormous impact on quality of life, keeping kids out of school and parents out of work. This coating on waiting room furniture, for example, could be a major step towards reducing this problem. The next step for the researchers will be to test the effectiveness against beta coronaviruses like the one that causes COVID-19. If the treated fabric would repel beta coronaviruses and in particular SARS-CoV-2, this could have a huge impact for healthcare workers and even the general public if PPE, scrubs or even clothing could be made from protein, blood, bacteria and virus repelling fabrics. At the moment, the coating is applied using drop casting, a method that saturates the material with a solution from a syringe and applies a heat treatment to increase stability. But the researchers believe the process can use a spraying or dipping method to accommodate larger pieces of material like gowns and can eventually be scaled up for production.